All right. Hey guys. So welcome back to my last video for the quarter. I hope everybody's staying safe out there. I understand that there's a lot going on right now. Uh, so this video is going to be a very quick uh, kind of concept review for your guys' final next week. So right now, here's kind of all like the big topics that you guys covered in the second half of the quarter. And so these are topics also based off of the sample finals that you've been given that I've seen. Um, so yeah, and so very briefly about each one of these things. First, we're going to start with trig integrals, right? So the idea with the trig integral is it's almost like a u-sub, right? Your goal is to substitute in a trig function so that you can simplify like kind of really complicated functions. And the reason that we like this is because trig functions have trig identities, and with trig identities we can manipulate those and we can get some like really nice ones, like that cosine squared plus sine squared is equal to 1, right? And so my tip is always look for easy substitutions, right? Those are substitutions that when you substitute it in, the derivative is already there, or when you once you do all the substitutions, things will cancel really nicely, right? Another thing is draw your pictures, because when you do a substitution, remember we solve integrals in terms of x, so when you go back, it's really helpful to draw your right triangle and kind of label your angles and whatnot. And then next, for partial fraction decompositions, so remember that's when we have an integral of a rational function, right? Or like just like a fraction. Basically what we want to do is we're going to separate the denominator, right? So we can do that with factoring or long division. But basically what we want to do is we want to take this denominator, right? It's going to have your unknowns are going to be your numerators, right? So that's going to be like I have on the bottom, that like ax plus b plus cx plus b. Or that should be a different letter actually. So should be something like cx plus capital D, right, over the two things on the bottom that are going to be the factored form of this thing right here. So, and then when we do that, basically what the point of doing that is we can integrate these fractions a little bit easier than we can integrate this whole thing, right? This whole thing could be pretty impossible to integrate, but you can integrate these two things separately, and usually that works out a little bit better. That's usually how we can tackle these rational functions, right? Next thing, we're going to talk about volumes, right? And so this is coming up on the more recent stuff. That's going to be the disk, the washer, the shell method, all of those things, right? My biggest things, draw your pictures and label your cross sections, right? So it's really hard to kind of envision like, okay, well, what does the graph of like this thing look like when we rotate it around like the y-axis or the x-axis, right? That's really hard, but what you can do is a lot easier to kind of imagine just or just a disk or a washer, right? And it's easier to kind of pinpoint those things, right? So make sure you have that and make sure you label them. Remember that volumes are just volume. Like it will always just be the area of the base times the height, right? And the idea with like the disk or the washer method is we're gonna take the surface areas of these shapes, right? And these surface areas, that's gonna be your base, right? That's gonna be either a circle or washer in this case. And if we take all those and we just keep stacking them up, eventually we're gonna get the total volume, because the volume is just the area of the base times the height. With the shell method, it's the same thing, where you're going to let that cylinder piece on the inside be the base, right? And so you're going to take the surface area of that and you're going to keep growing it out, like how when you drop like a pebble into the water and it ripples outwards, right? And eventually you're going to get the whole volume. Next thing, area between curves. I like to think of that as kind of we're taking strips And so you can think of them like Riemann sums, where the idea is we take an infinite amount of infinitely thin strips and add them all together, we're going to get the total area, right? So that's how we kind of treat the area between curves. And then last thing that you guys have covered are improper integrals. And so this is kind of a nice break for you guys because it bit volume stuff, area between curves stuff. That's pretty difficult, but improper integrals basically just mean if you're taking any definite integral and there's infinity in it, you're gonna replace that infinity with a letter. I chose A, and then you're gonna take the limit as A approaches infinity of the integral of whatever to A. That's an integral that you can solve, right? And then after you kind of solve that integral with A in it, you're gonna take the limit. And so here I have a couple of useful limit properties that might show up, right? So anytime we have the limit of 1 over A, remember if A gets infinitely larger and A is in the denominator fraction, the fraction as a whole gets smaller and smaller and smaller. That type of thing. And then the idea where you can break up the limit. So like the limit of B plus A is the same thing as the limit of B plus the limit of A. So yeah, anyways, those are kind of like the big concepts that you've touched so far for this whole quarter. So yeah, that's it for me. It's been a pleasure to make these videos for you guys and watch you learn math. So thank you for watching. I hope you learned something. Stay safe out there, everybody.